Hello, good morning. And I think we're the only ones on here, so I'm going to ask, were you pleased with your score?
I got an 89.74 somehow.
Yeah, see, I told you you didn't need to worry about it.
I literally thought I bombed the crap out of that test.
Yeah, well, you need to look back and see which ones did you know and which ones were just lucky guesses.
I think some of them were lucky guesses. I somehow got most of the calculations right,
Yeah,
like
well,
the fill in the blank ones.
yeah, that's great.
Yeah, that literally has like saved me for the rest of this course.
Yeah, you're in good shape.
Ugh. It was just kind of crazy to see how much some people's tests curved. You're still muted, Dr. Woodrum.
Here we go. Yeah, it made for a lot of A's to have that bonused out like that, and still a lot of people are pretty disappointed with their results.
Yeah. A couple, one of my friends, she got like 101 on it.
Yeah, yeah. I haven't looked to see what the highest score was, but
It was like 115.
yeah. Oh, was there one that one? So somebody had a perfect score basically, and
Yeah.
so
I just remember because like one of my friends, I think she's in Dr. Nunez's class, but she took that exam. Thought the first exam, she thought she failed the crap out of it. Ended up getting 100. I was so mad at her.
there's somebody who doesn't have a really good feel for her knowledge, I guess.
No.
Usually it's the other way around. People think they really know it and they don't. It's unusual to somebody who does know it, really just doesn't have any confidence.
That's exactly how I felt about the first exam. I was like, all right, I got this. This is easy. Bam, 73. I was like, oh.
But it is hard to really, that's, the most, it's a really hard lesson to figure out, but it's really important to, as a student, to get a good feel for, do I know this or do I not? And those who don't do really know it well, but don't really feel like they do, they realize, okay, there's still a lot that I don't really understand, because there's a lot of nuances that, so they're kind of tagging in on those things that they kind of are feeling a little shaky on, and focusing on that, I guess, and making them feel like I don't know how to do this at all. But
Yeah.
once you sit down at a test, you would think that you'd say, oh, yeah, I know this. I got this.
Yeah, we did a lot of acids and bases and stuff in high school, so hopefully I remember most of that stuff.
Yeah, well, good. Yeah, our next little jaunt will be hopefully not too bad. It's when we start adding it together with, well, really, when it gets challenging, it's not right here at the beginning. When we start mixing acids and bases together, and they have to react, and then we have to consider the equilibrium. That will be the biggest challenge of the semester. It's when we start dealing with calculating pHs of titrations and buffers. And I remember as a student being a little bit, I really do still remember the feeling of trying to learn about buffers and not quite getting it when I was a student.
Yeah, we didn't learn about buffers, so that's gonna be something new. But
Yeah. I'm going to mute again, Aiden, but if I start talking and I haven't muted, I haven't unmuted, you let me know.
Yes, ma'am.
Well, good morning, everybody. Good to see you. For those of you who I can see, we're going to start working our way through acid-base chemistry. We first learn a lot about the concepts of acids and bases and the idea of pH and pOH, and we'll be working on that today. And then once we have that under our belt, we will start seeing how we can combine chemical equilibria problems and in doing it in the world of acids and bases. So each of you have now know what you got on your second exam. And I've had a lot of communication with students who have wanted to meet with me and talk to me about their results and ideas of study changes that might need to be made. If anybody else wants to have those conversations with me, I would be very happy to have them. I do want you to know that, it feels like sometimes this course is overwhelming with the amount of information that we are requiring of you to understand and utilize. And I want you to know that this is not like the University of Kentucky decides to make your life miserable, so we're going to give you a lot to learn. But general chemistry is general chemistry across the United States. What is expected is similar from one institution to another, whether you go to a community college or you go to a Harvard. If you're going to take Gen Chem 2, it's going to have a lot of the same topics. And I know this because I served on the American Chemical Society's exam committee, and we sent out a questionnaire across the United States to just make sure that we understood what everybody is covering. And I know that what we expect and what's expected across the country is very, very similar. So it is what is needed. For those of you who are moving on to other sciences, there will be topics that you will utilize. For those of you who are taking the MCAT or the dental entrance exam, you're going to be seeing these topics on that exam, especially as we move ahead and start talking about acid-base chemistry, because a lot of that is very important in biological systems. So without further ado about that, let's just move on to what we see on the screen here. There's two homework assignments that I have assigned there, which pertain to today's material. One of them is just about the conceptual information behind acid and base chemistry. And the other one is working with pH, pOH, concentrations of acids and bases from that information. So giving you practice with the foundational information that we utilize in acid-base chemistry. All right, so I don't think they will take you a long time to knock them out. And if you want to linger with me after we get done with our formal time together, you might want to do so and ask me questions as you go. You'll notice there that there is kind of a jump ahead to a topic. So we have acid strength, calculations of strong and weak acids, and mixtures of acids. And then I popped ahead quite a bit. So those of you who, you've got the set of notes, and they're kind of in order of not how I cover it, but how they are in the chapter. The reason I pop ahead here, and you'll have to kind of flip forward a few pages in your notes, is because I wanted to cover everything about acids before I start talking about bases, instead of covering some of acids and about bases and go back over to acids again. So the concept of polyprotic acids, I wanted to go ahead and cover right there. So again, my plate posits have the number 14 with it because they were designed with a different textbook, but these are found within chapter 16 of our integrated general chemistry textbook. And the last thing I have there on that slide is about Thursday's class this week. I have another doctor's appointment, and it may be that I'll be able to be there by 11, but I don't want to push it, and I don't want people sitting there waiting for me. So on Thursday's class, we'll just plan on starting a little later. Let's just plan on starting at 11:30. I will finish my formal time by 12:15, but I will linger as long as people want me to linger after class, for those of you who want to stay and work on your homework with me after that. Okay, so just be aware of that. Put it on your calendar so that you're not shocked by nobody's there. I will have an announcement on Thursday in Canvas to that effect, but that is what we will do on Thursday. I thought about just making another set of recordings, but I can make it to class. I just am going to have to be late. All right. So what we're going to do today is we're going to make sure that we have a good feel for a working understanding of the concepts behind acids and bases, the concepts of what a conjugate acid-base pair is, and what we watched about coming into this class. And also we'll practice a little bit with calculations pertaining to pH. And I want you to hang around for that, because I'm going to give you some warnings to be aware of as you do your sapling. It is really easy to do all the right work and get the wrong answer in sapling. And I'm going to tell you why that would be. And it's just the nature of the numbers that we're using. So I'll talk about that when we get to that portion of it. But before we get started, I want to ask, is there anybody who's got any questions that they would like to bring to my attention about anything that they watched coming in today, or questions about the exam, or whatever it might be? I want to give opportunity to you guys to ask.
So I know in the announcements they stated that the exam had too many calculations. Do you know why that is? Is it just like the system, or?
Well, what it was is there's multiple people who put the exam together. I really blame myself, because that's usually something I check very heavily. I will do two things: make sure there's not too many calculations, and work through the exam and make sure I can do it in 20, 25 minutes, because then I can feel comfortable that my students mostly can complete it. I didn't do that quality check. I didn't notice how many there were until it was too late. And so that was the reason. And so we thought, if we're expecting students to do this many calculations, and it was a challenge, and it caused a lot of people not to finish well. The best way that we could address that was to say, all right, we'll consider 4 of those questions bonus, basically, is what it comes down to, by taking it out of 26. So that was just an unfortunate, poor quality control check on my part when it came to counting up that. So it's not going to happen on the next test. We're already making sure that is high on our radar, that there is not going to be 17 calculations. I think that's what it ended up being. I like to have 12 or 13, 14 at the most, if we're making sure that there's ample information in the problem to where you're not having to go, scrounge up a molar mass and things like that. So we got it high on the radar, and we won't let it happen for exam 3.
I have a question. How come we don't get the full amount of time? It just feels like, for me personally, and I'm sure it's other people, this isn't like a far-fetched idea, but like, it seems like it's a test on how fast we can perform chemistry. It's not about how well we can perform it.
Yeah, I can understand that feeling. I know this, the better you know it, the more it is. The better you know it, the more you will finish on time. And this is why I say that. The delay in finishing is not in the doing of the calculation for most students. The delay in finishing is because as you look at the question, there is this time spent scratching the head saying, oh, I know I can do this. I've seen it before. How do I get started? And that's typically where the delay is. And that's why I can finish it in 25 minutes, not because I'm some whiz bang at calculations and I'm the world's fastest puncher of buttons on my calculator, but because I have no delay whatsoever between seeing the question and getting started. So the more that you will practice problems and get yourself with that fluency built in, the more likely you will be able to finish it. And it is really that recognition. So you've got to work when you're doing your homework. You've got to work on that recognition. And some of the things I recommend for students that they should do is when they finish doing a sapling problem and they finally get that congratulations, you got it right, green check mark, you stop and you look back, what was asked, what was given, and why did I start it out this way? So that I'm starting to recognize that. And that is the typical thing. So it is a judgment, truly, in your level of fluency of knowledge of the material. And it's a philosophy that that I know that students don't agree with, because they'd like to just say, let me show you what I know, no matter how long it takes me to get there. And that's just, it is going to be one of those things that you will be judged on your fluency. And you can build that by practicing more problems and thinking about it a little more intentionally when you finish. Instead of just moving to the next one, you got to do something that drives it into your long-term memory and say, okay, I'm going to stop right now while it's fresh in my mind, and I'm going to think about, what did I do and why did I do it, so that the next time I see it, I can pull that fluency up a little bit. Somebody else had a question or statement, I think.
And we don't have to necessarily do it right now because I know we have material to cover, but could you go over one of the questions on it, like walk through one?
Yes, I'd be happy to. Let's wait till we get through the formal time, and then you just ask again when we get towards the end, okay?
Okay.
Anybody else?
So is our grade gonna change for the exam because
I'm
of
sorry, say that again.
is our grade gonna change on the exam because of the whatchamacallit, the bonus
Yes,
points or whatever?
there was an announcement posted on how that is done. So you'll see a grade within the exam the Chemistry 107 exam portal where you took the exam. There's a grade there. And then we took that grade. We had to make one correction on one of the questions. So that, I can't remember the number, but that's announced in the announcement. And then we took however many points you earned and divided it by 26 to determine your grade. And that was what was posted into our course, into your grade book, into our regular course. So what you see in the grade book of your regular course is a reflection of that change.
Okay.
Okay. Anybody else? Okay, let's move on. So we're going to be using our notes. So make sure you have them out and be reading through them and see if you can come up with good answers for these questions. I'll be using our polling app quite a bit for today's class. All right, so there's the first one. I will launch the poll, and we're going to try to figure out which are our conjugate acid base pairs for that reaction. So I've listed a reaction for you, and you're finding the conjugate acid base pairs. Look at the definition in your notes and come up with one of those answers. All right, you've had a chance to look at them. I'd sure like to have everybody give me their best guess. And even if you don't know, pick one while I count down from 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, nearly everybody who responded, and I didn't get everybody to respond, so if you didn't respond, try to participate with me, but nearly everybody who responded picked at least one of them. The right answer is really, let's see if I can get my pen to work here. I think I figured out a new system here. So both B and C are conjugate acid base pairs. And so most people picked that. Now you got to be sure, some of you picked A, And this is the one that is definitely not a conjugate acid-base pair, because to be conjugates, they have to be exactly the same except for different by one H plus. Okay, one of them will have the H plus, the other one will not, but everything else about them are exactly the same. So that's what we see here with B. They're exactly the same, but the only difference is an H plus. These two are exactly the same except for an H plus on one of them and not on the other. So that's what you're going to look for. And they are across the reaction from each other. So when you do that proton swap, they are across from each other in the reaction. So there we have our conjugate acid-base pairs. Okay, so that will be an expectation that you can recognize conjugate acid-base pairs. Now, let me give you one that is commonly missed. If you see something like this, H2SO4 and SO4 2 minus. A lot of times people want to say that those are conjugates, but they're not, because they're not different by just one H plus. These are different by two H pluses. I've pulled off two hydrogens. And so these are not conjugate acid-base pairs. The conjugate acid-base pair of either one of these would be HSO4 minus. Okay, so that would be the conjugate of either one of those would be how that would work. Okay, any questions about that one? All right, let's go to the next one. Select the false statement. So read through those statements and select the false one. Oh, I gotta hit the launch this thing. All right, there it's launched. All right, you've had a chance to read them. I'm gonna count down from 10. Let's have you pick one. Best guess. If you don't know for sure, at least try one. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, good. We got many of you in, 82% picking the right answer, and the right answer is C here. If we had called this an Arrhenius acid instead, then that would be correct. But there's two different definitions, and the Bronsted definition always has to do with when we use this Bronsted definition, that always has to do with an H plus. I like to call it an H plus swap. Okay, we're swapping an H plus between two things. We are donating one, accepting one, and that's how we define, did you donate or did you receive that H plus? So that is why this one is the false statement of the four there. Any questions? All right, let's go to the next one. What is the conjugate base of H2PO4 minus?
I had a quick question about the
Yes,
last
sure.
question.
Let me back it up.
So I understand that for the Bronsted description, it's without water. So exactly how does that work without water?
It doesn't have to be without water. It just doesn't need water as its definition. Okay. So in the Bronsted, the Arrhenius definition has to have water, and it's what it produces when you dissolve it in water. So you're producing H plus ions or H2O plus ions in water, and you're producing OH minus ions if it were a base. In the Bronsted, it can still have water, but we don't define it by its water. We define it by whether it donated an H plus or accepted an H plus. Okay, so you could definitely, once it fits the definition of being an acid by the Arrhenius definition, it is going to fit the definition of being a acid. Let's say it was an acid in the Arrhenius definition. It will be an acid in the Bronsted definition as well, but not vice versa, because you could have something that is a proton donor and there was no water for it to donate to, so it would not go down and fit the definition of being an Arrhenius acid. Okay. All right. I'm gonna let my dog out. She's scratching at the door. I'll be right back. Oh, what's that? Okay. Oh, out. Out of that. Okay. Back to the other one here. This is the one that you're going to be using the poll to answer. I want to know what the conjugate base of H2PO4 minus is. All right, I'm going to count down from 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, so we did pretty well on this one as well, but I caught a few of you with a really common mistake. So let's talk about that here. The right answer is A, but I had quite a few people picking B. And let's talk about how we know it's the one and not the other. If you're looking for this guy's conjugate base, you have to think about him acting as an acid. Okay, we're going to have him act as an acid and donate a proton. So he's going to be a proton donor. Wish that Dr. Woodrum didn't keep showing up there. I had to go to another system because I lost my digital pen. I think my dog must have taken it outside and eaten it. I don't know, but I can't find it anywhere. So I'm trying to do my iPad and it just keeps saying Dr. Woodrum everywhere. But anyway, I digress. H2PO4 minus, it has to act as an acid if we're trying to find a conjugate base. So we take it, we think about it donating an H plus, so we take an H plus away from it. So there's going to be one less H, and that also will change the charge. If you're taking a plus away, it's going to become a little bit more negative. So it's going to be more negative by 1, okay? So this is actually the conjugate acid of H2PO4 minus. Conjugate acid would say, okay, this guy's going to act like a base. If this guy acts like a base, it's going to be a proton acceptor. And once it accepts, that would make the H3PO4 the conjugate acid of it. Okay, so you have something like this, it can behave as an acid or a base because it has a proton to donate. It also is negatively charged. Okay, it's more likely to want to accept a proton than donate, and we'll talk about that later. But it can do both. Any questions about that one? All right, let's see what the next one is. All right, here we go. Starting to get into KWs here. This is a real common misconception. Let's see what you all can do with this one. Which is the false statement about KW? Looking for a false statement. All right, you've had a chance to read them all. Let's pick one. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, you did very well on this one. 87% picked the right answer, which is C. And actually, when I go in and talk about this, we find that it's the opposite of what's written there. It's actually going to get larger with increased temperature because the reaction is endothermic. So as you raise the temperature, it pushes it to the right and makes it get larger. Okay. Now, this is, of course, true, and you will always assume this value unless we tell you otherwise. Okay. Almost every calculation, it will have a statement in there that it's happening at 25 degrees Celsius, and that will be the kW that you have. It is always equal to this. This is its expression for sure, and it is the K expression for this one specific reaction. That's what it is. It's for that reaction. So when we look at a kW, it is for that reaction. But where students a lot of times go astray is they think that this is true for all temperatures. Okay, so make sure that you realize that it only applies when you're at 25. Okay, any questions about that one?
Could you repeat what you were saying about endothermic?
Sure. The value actually gets, let me go back. Yeah, my pen's working. The value gets larger. It gets larger, and I've got to make sure that pen is a little less fat. All right. It gets larger with increased temperature because the reaction is endothermic instead of exothermic. So this is how we would correct it. Okay. Endothermic means you would put heat as a reactant. And if you raise the temperature, it would push it to the right. And that would increase the concentrations of those things and give you a bigger K. All right. You will see somewhere in your notes where I gave you K at various temperatures, and you see that it increases as temperature goes up. At least I think you have a table with some values with that.
So are both statements correct?
What's that?
Are both statements correct? The one that was written and the one that you wrote over it?
No, the previous statement was false. It does not, it would get smaller with decreased temperature because it's endothermic, but it's getting larger because it's endothermic, not getting smaller because it's exothermic.
Okay, thank you.
Be right back. Yeah. Let's see if that works. Okay. So let's clear this slide and move to the next one. All right. Select the incorrect matchup. All right. So look for those and find the incorrect matchup. I might be able to turn off that little, let's see here. Ah, there we go. I think I got rid of my name showing up across that. All right, just pick one. Looks like most people are zoning in on A and B as being an incorrect matchup. Let's count down from 10, 9, 8. Right, pick one. 7, 6, 5, 4, 3, 2, and 1. All right, so really with, that probably doesn't matter. Let me, so we got more people picking A than B, but it's not a great matchup here. We have 66% picking this answer, and that is the correct answer. And understanding the magnitude of these guys is kind of, it's something you just need to spend some time on the mental exercise. We know that if we're considering H3O plus concentration, that a concentration of 1 times 10 to the minus 7 is neutral, okay? But this is only at 25 degrees Celsius, okay? That would be neutral, and that would be a pH of 7. So if we have a number that is greater than this, okay, if it's bigger, it's going to be acidic. This number is not bigger, it's smaller, okay? So it has to be bigger than 1 times 10 to the minus 7 in order to be acidic. And I know that a lot of people look at that 9 and say, well, that's bigger than 7. But remember, it's raised to the negative 9, which takes that decimal place further over to the left and makes it an even smaller number. It's an easy thing to mess up. It would also be true that OH minus concentration is 1.0 times 10 to the minus 7 if it's neutral, okay? So these are all the neutral numbers that we would have. So if it is less than that number, it would be acidic. Okay. If you got more than neutral of the OH minus, it's basic. So if it's less than that, it would be acidic. So that does fit what we have here with B. That is a number that's less than what neutral would be, and that would be an acidic solution. So that's why B, which was commonly chosen but incorrect, why it is incorrect. Okay, it is if it's less than, wait a minute, my brain just had a hiccup. Oh, what did I just say? If it's less than this, it's acidic, and it's less than that. So why is that not true? It looks like it's true to me. Let's verify. Is anybody seeing any error in my logic here? If it is less than this amount for the OH minus, is what I'm looking at, it would be acidic. That is less than that number. So it is acidic. Both of those are true statements. Unless somebody can help me see where I am going astray with my logic, it looks to me like both of those. Oh, wait a minute. We're looking for the incorrect. Dang it. That's why I don't like choose the false statements on a test, because you go and you start looking for the true statement. Okay. So this is acidic. I'm not looking for a false statement. That is a true statement. But this one is our false statement. Okay, I've got it now. I didn't have a mistake on there after all. Now, I've given you a little bit of a hiccup in my explanation, so give yourself a chance to look through those statements. Make sure you understand why A is false and B, C, and D are all true before I go to the next one.
I have a question.
Yeah.
On an exam, would this be a type of question that we should be able to do like quickly? Because it's easier for me to see which statement is true or false when I do a calculation, not by just looking at it. And
you can absolutely bet that something like this would be expected of you.
Like
you need to make
them, because it takes time to do calculations.
It
I mean,
takes
like,
time.
how fast should we be expected to
Oh.
think through this question?
How fast? I don't know the answer to that. I would expect you to think through it and it takes some time. I would not expect it to be an instant thing at all.
Okay.
What I would want you to be able to do is realize what neutral is. So all of these statements of what I have here, I would want you to be able to know fairly quickly what neutral is. And then you would have to think through the logic of what would it mean for it to be acidic or for it to be basic. It would not be something that I would expect any student to look at that and say, you can do that fast. Okay.
Okay. Thank you.
But yes, I would want you to logically put yourself through that without it being a memorized statement, beyond the memorization of what you see playing out across that.
I have
I
a
was able to
question as
get-
well.
oh, sorry.
We'll go
Oh,
with Brooke.
sorry.
Go ahead.
So I'm just having trouble like understanding the difference between A and B, like because I see them as pretty much the same
Yes.
outside of just the H3O and OH.
That is
but-
a great question. And so what I'm going to do here is I'm going to pull up my whiteboard and kind of explain it a little bit more thoroughly. So give me a second to see how I do that with my little, where are you, baby? Oh, there it is. Okay. So I'm going to see if it'll let me do this. Yeah. All right. So seeing the difference between them, I'm going to do neutral for all of these three things: pH, H3O plus, and OH minus. Okay. So neutral for H3O plus is 1 times 10 to the minus 7. pH is 7 and OH minus is 1 times 10 to the minus 7. So now we're going to go to acidic. Acidic. To be acidic, you're going to have a H3O plus that is greater than this number. Greater than 1 times 10 to the minus 7. That's your first thing. If you've got more than pure water, it's going to be acidic. So I'm going to give you an example in a nice different color, something like 1.0 times 10 to the minus 5. That's greater than 1 times 10 to the minus 7. So that would be acidic. Basic would be less than 1.0 times 10 to the minus 7. So something like 1.0 times 10 to the minus 9, that's less than that. So let's just start with that. Does that part make sense to you?
Yes.
Okay, so then we can add to that our pH. If it's basic, it is going to be a number that is greater than 7. Okay, so my example of this guy would have a pH of 9. And if it is going to be acidic, it's going to be less than 7. And the example of the one I have written here in red would have a pH of 5. So that's our pH range. So where it gets complicated now is over in the OH minus concentration. And this is what we have to keep in mind. Since we know that Kw equals the H3O plus concentration times the OH minus concentration, if the H3O plus goes up, then the OH minus must go down. And that's the little piece that is making the difference between A and B. We're starting to look at in B, the OH minus concentration. Okay, so let's consider acidic. If it's greater than 1 times 10 to the minus 7, there doesn't look like I was a minus there. If it's acidic, that's greater than that. And if the H3O plus is going up, then the OH minus has to be going down. So to be acidic, it will be less than 1 times 10 to the minus 7. And that's the key there. Does that make sense?
Yes, I see it now.
Yeah. So
Thank
then,
you.
of course, under basic, if it's going to have a lower concentration of H3O plus, then it's going to be a greater concentration for this guy. And then we can give some nice examples for acidic. A number that's less than this would be something like 1.0 times 10 to the minus 9. Something that's greater than this would be something like 1.0 times 10 to the minus 5. But it all stems from, this part all stems from that. Okay. All righty. Let us go to, back to the PowerPoint. And we'll go to the next one. All right, now I just want you to spend a little time calculating this. So you should be able to, if you're given any one of these 4 things, you should be able to calculate the other 3. So you're just going to start working your way through it. I'm going to be quiet for a little bit. And then I'm going to just start pulling up and seeing how you did. Okay. The first one I will pull up will be whether or not this solution is acidic or basic. Okay. I'll pull this one up here in a little bit, but just work on a little bit. And if you have any questions, feel free to ask, and I'll be happy to help you through some of these calculations. And if you want to just start by answering each of those numbered ones and then go back and start filling in the rest of the table, that might be a good efficient way for us to be able to go through the answers. So where the numbers are, see if you can calculate those first and then fill in the rest of your table. Jot these down on your paper, because when I go start and ask you questions 6, 7, 8, 9, the table's going to disappear. So make sure you have kind of this table copied down before I pull up the questions to see what your responses are. All right, I'm going to start pulling them up unless somebody says, no, wait. And if you say no, wait, that means you're still copying the table down. Does anybody need me to hesitate? Okay, So we'll pull up the first one. The first one is is which one of those did you select as the, wait a minute. Okay, yeah, I'm asking you whether it's an acid or base, and I want to know which one of those you chose for that. Somehow, there it goes. Relaunch my poll, and there we go.
Dr. Woodring,
Yes.
I'm trying to calculate the concentration of H3O plus
Mm-hmm.
for this line in the table, and I put it in my calculator and I get an error.
All right, so let me back up to the table. I'll come back to this slide for everybody in just a minute. You're trying to calculate this part?
Yes.
Okay, so what are you, tell me about what are you trying to do on your calculator in order to get that?
10 to the negative 10.85. That's what I got as a pH for that.
Yes, 10 to the negative, that's correct. Okay, so now how are you putting that into your calculator?
I was using the E button. I now see that that was wrong. I should do
All right,
10
yeah.
to the.
Yep. Here you go. 10 to the
Thanks.
X button. Yep. See if that doesn't give it to you. Although I'm surprised the other one gave you an error. Unless
No,
you
I
were,
still get an error.
yeah. So it's maybe an order of operation thing, and different calculators are the same, different ways. So if you put
Okay, I got it now. I don't know.
all right, yeah.
My
because
brain was glitching, I guess.
Your talking about what to do was perfect. I knew it was just a matter of how you were putting it in your calculator.
Thank you.
Uh-huh. Giving me an answer for number 6. Remember where number 6 is in the table. I'm trying to decide where there is an acid and a base. I gave you a POH. It is not my nature to think about the magnitude of POH, get my acid or base, but you could, all right? But I didn't give that as, well, I did give that as one of the choices, didn't I? I sure did. Looking at it just as the POH, you can come up with whether it's acidic or basic. But one of these 4 is how we know whether it is an acid or base correctly. All right, so I'm going to give you just a little more time to think through this. This is really a little bit of a calculation, maybe, and a lot of a concept.
The POH is different on the chart and then on the answer choices. It's just
Oh,
3.0.
3.06. Oh, it sure is. 3.15. Work with the 3.15. Let me write that on my screen here. I don't know where I got that 06 unless that was left over from who knows what. Doesn't make a difference in terms of which one of those you choose. But we'll keep our eyes open on the next ones to see if I've got the wrong ones. That's my choices. All right, I'm going to count down from 10. All right, let's see you pick one for me. 10, 9, 8, 7, 6, 5. Come on, guys, pick one. I've lost an awful lot of you. 4, 3, 2, and 1. Okay. About 80% of you chose to answer, but of those who chose to answer, I have 71% of you picking C, which is the correct answer. It is a base. Okay. Now, some of you picked A, that it's a base, but you said it's because the H3O plus is greater than this. The H3O plus is greater than this. That would be a sign that it's acidic. And it's not greater than that. If you went through and calculated, you should have actually had a number that is less than that. It's raised to a higher negative power than 10 to the minus 7. Now, you can look straight at the pOH. We know that pH is 7 when it's neutral, and pOH is 7 when it's neutral. If pH gets greater than 7, it's basic. Uh-oh, what did I just do? I have no idea what I just did. All right. If the pH is greater than 7, we know that it is acidic. And if it's less than 7, we know it's basic. On the side of the pOH, it's the opposite, okay? If the pH is greater than 7, then it's going to be basic. And if it's less than that, it's going to be acidic. So you can go to the level of the pOH to make a judgment on this one. But we have a pOH that's less than, and the two together add up to 14. And so if the OH minus is less than 7, the pH is greater than 7. And that's where I think when I'm thinking about acidic or basic. That's just my favorite go-to. All right, questions about that one? All right, you're calculating. So let's see, did I have the same number there? 4.9 times 10 to the minus 4. 4.9 times 10 to the minus 4. Okay, yes, I do. So which one of those is the answer you came up for where the number 7 was in our box? You were given an H3O plus of 4.9 times 10 to the minus 4. What was your pH?
At some point, would you be able to go back to the chart? Because I didn't get what the answer or what the question for Q9 would be.
Oh, sure. I'll do it right now. Okay. Everybody else just pause putting an answer in.
Thank you.
You're welcome. All right. Back to putting in a choice for number 7. If you were given the H3O plus of 4.9 times 10 to the minus 4, what was the pH?
Dr. Woodrum,
Yes.
could you go over again how to do like the sig figs when you do, like go from like concentration to pH and pH to concentration?
I definitely will. And looky here, I have a little comment to remind myself to do that. So give me a moment and we'll do that.
Okay.
Very timely asking.
This is like a question that's on topic, but sort of off topic at the same time. But what substance has like the highest pH or is like the most acidic out there?
Well, it all depends upon what the concentration is. I can tell you that of your standard acids, you can make the most concentrated acid of probably sulfuric acid, H2SO4. It's a strong acid. You can make a solution that's like 98% sulfuric acid and 2% water, which is a really high concentration and therefore would have a very low pH. And when we're saying low pH, don't think that 1 is your lowest. You can have negative pHs. And the more negative it goes, the more acidic it is. A lot of times people think that they get a negative number, they must have done something wrong. But you can easily have, if you have a concentration greater than 1 molar, you're going to have, or greater than, greater than 0.1 molar, it's going to be, or I should say it this way. If it's greater than 1 molar, it's going to be a negative pH.
Are we going to be dealing with any questions with negative pHs?
Yes, I know that there's some sapling questions where the pH ends up being negative, and it always throws students off when they get that. I don't know if everybody would get one with a negative pH, but I know that that was the case in some of the sapling. All right, I've got a lot of you in, so I'm going to count down from 5, 4, 3, 2, 1, and we did well. 84% of you picked D. Not everybody picked D, but 84% picked D. So how do we get that? We simply will take the negative log of the H3O plus concentration, because that is the definition of pH. pH is just something that helps us give a concentration in a quick way. I wouldn't say it's easy. It's easier to say the H3O plus is 4.9 times 10 minus 4, but that takes a lot of writing. And if we say that the pH is equal to, and we plug it into our calculator of that 4.9 times 10 minus 4, you will get 3.31. Now, if anybody got an answer other than 3.31, and you thought you were doing that, it's a matter of how you're using calculator possibly. So make sure you use your exponent key. Start getting used to using that. Don't use 4.9 and then times and then 10 to the X key. Use your exponent key, which for many calculators is EE. I believe that is the go-to for the TI world. Yep. Look for that EE, and it'll treat that number as one number, and you don't have to use parentheses and a lot of rigmarole. Now, the question was asked to explain sig figs, and this is going to be important when you're doing your sapling. Sapling is not judging your sig figs, but they know what the right answer is according to sig figs. And it is really easy on these small numbers to report too many significant figures or too few and fall outside of your 2% range. So when you're answering, you're going to want to make sure you're following the sig fig rules. I've already had somebody ask a question on Piazza where they did all the right work. They put in too many significant figures. Sapling counted it wrong because they were outside of the 2% range. Okay, so here it is. This number has 2 significant figures in it. Okay, that is how you count sig figs. When you report a pH, you want it to have the same number of decimal places as it had significant figures. Okay, so basically what the 3 is telling you is a rough place of where that decimal point was in the original concentration. It is not a significant figure. It is giving us information about the decimal place. It is the last 2 digits that are the significant figures of a pH, but we'll call them decimal places, okay? So you've got to make sure that you report this to 2 decimal places. And because sometimes, okay, now this is where the situation was for the student who asked me about Piazza. When she did the work, she got something like 1.26 times 10 to the minus, I can't remember what it was. Let's say 4, okay? And they put that in and it said, nope, you're wrong. She's like, how can I be wrong? You know, I'm just taking 10 to the minus pH and that's giving me this number. But they should have only reported 2 significant figures. And when they did this, they would put it as 1.3 times 10 to the minus 4. Okay, 1.3 times 10 to the minus 4 was what they were looking for as the right answer. And 1.26 is greater than a 2% difference, simply because this is such a small number. If you take 2% of 1.26, you get a really tiny percentage off. And so you got to be careful, okay? If you feel confident you're doing your sapling and you're doing all the work correctly, double check your sig figs. If you feel like you're doing all the work correctly, you've double checked your sig figs and you still don't get the right answer, please post it in Piazza. Tell me what you did, what you got, and I can do a background look at your particular question and see where you went astray. It is probably the biggest frustration is this world of putting in PHs for students, not because they're doing their work wrong, but because their sig figs are off and it's counting it wrong for that reason. Okay.
Will we have to watch the tests as well?
What's that?
Will we have to watch that on the tests as well, or is that
You
just
will watch that on the test as well, but we'll be telling you. We won't leave it up to you. So if you are putting in a pH, we'll say, report your pH to 2 decimal places, and then you won't have that error. Or if you're putting in a concentration, we will say, report your answer to 2 significant figures. So you're always watching for what we're telling you. And if you are reporting it to the right number that we're giving you, you will fall within that 2% range just fine.
Okay, thank you.
Uh-huh. But Sapling won't do that. Sapling will expect you to put it in the right significant figures. They'll be looking for the right answer that was determined with the right number of significant figures, and you're going to want to match that. It won't always be a problem because if your concentration were really big, like 9.6 times 10 to the minus 4, okay, that 9.6 is a big number. 2% of it gives you a much bigger range than if a number is 1.3 and you take 2% of 1.3, it doesn't give you very much of a range. All right, let's move on. Let me clear that screen there and do the next one. All right, so for question number 8, I gave you the OH minus of 9.2 times 10 to the minus 4. I'm going to double check that I didn't have a mistake on that one. 9.2 times 10 to the minus 4, yes. And you're telling me what the H3O plus concentration is. Open the poll.
Could you slide forward to the next slide? Because I think you accidentally went.
Oh, you're right. I did the wrong one there. There we go. I must have bumped my mouse. Okay, if you're filling in all the little boxes, stop for just a moment and calculate this one. Let's get an answer in for this guy. If you know the OH minus is 9.2 times 10 to the minus 4, this is where I had the question 8 in your box. Tell me what the H3O plus concentration is. Give you just a little bit more time to get your answer in for this one. All right, 5, 4, 3, 2, and 1. All right, we nailed that pretty well. 91% of you got the right answer. which is B. Okay. To get the right answer, you should take this expression. You should put 1 times 10 to the minus 14 in for KW. So then you're dividing. You're basically taking that 1.0 times 10 to the minus 14, and you're dividing by the 9.2 times 10 to the minus 4. And that is going to give you the H3O plus concentration. If that's what you thought you did, and that did not give you B, then you've got an error in the use of your calculator, and you ought to hang around and let's talk through how you're using your calculator. All right. Let's see what's next. I think I'm going to clear that, and I'm going to jump ahead to this question, okay? Because it's already afternoon, and I want to make sure you got this one, because this is an old exam question, and students did terrible on it. Terrible, okay? But you have all of the skills and all of the information in your notes to be able to find the right answer here. So let's see how you do on this one. I want the H, and remember, that's the same thing as H3O plus. If I were writing this test question, I would have written it as H3O plus, but they're interchangeable. What is it for pure water? If you know the KW for pure water is 3.2 times 10 to the minus 14. Let's have you pick the answer, knowing that it's a little bit tricky if it was done terribly on the test.
Dr. Woodrum, I have a question.
Yes.
So the answers that you've given us have 3 sig figs. Why is that? Wouldn't it be 2?
Yeah, they should all be only 2.
All right,
so
thank you.
I wasn't involved in the writing of this exam question, and they should not be this many. You can't know it any better than the KW you have. Very good question, actually. Thank you. It would have been better as a 1.8, a 7.0, a 1.0, and a 4.5. Okay, what I'm seeing with what's popping up here is you all have a good heads up, and nobody's picking what got picked over and over and over again when this was an exam question. When this was an exam question and nobody's picked it. And I'm so pleased with you guys with your heads up. Nobody has picked B, and that was chosen over and over and over again on the exam because they were just tuned into if it's pure water, it's 1 times 10 to the minus 7. But we know it is not pure water at 25. The reason it is this at 25 is because the KW equals 1 times 10 to the minus 14. Okay. But since we have a KW equal to this value that we're given here, I'm just going ahead and talking through it, even though not everybody has responded. We know that we have our KW expression. We know that if it's pure water, then the amount of H3O plus, I'll underline it, has to be the same as the amount of OH minus. For pure water, every time you make an H3O plus in this reaction, you're going to make an OH minus to go right along with it. So those two values are the same. So we would take our KW of the 3.2 times 10 to the minus 14 and set that equal to X times X, or X squared. Take the square root of that number, that's a 14 there, and that will give you the answer of A there that you have there. Let me double check that gives you A because I didn't calculate it. 3.2 times 10 to the minus 14, and take the square root 1.8 times 10 to the minus 1, 2, 3, 4, 5. Yep, that's it. Okay, so that is how you come up with that answer when it's not pure water. And if the question says, well, what's the pH? Then people would pick a pH of 7 because it's pure water. But if you know the H3O plus concentration is equal to this number, you would need to take the negative log of that number in order to get the pH. So when I take the negative log of that number, I get 6.75. The pH of this pure water would be 6.75, not 7.0. That would be another tricky one for students because they're always thinking in terms of a temperature of 25 degrees Celsius and all of those cutoffs that we're used to for 25 degrees Celsius. This question is testing your knowledge of understanding that KW does play a role and temperature does play a role in all of that. Okay. All right. So that's it for me with you guys today. And linger, work on your sapling if you want, ask questions. And I know Aiden had a question about the exam that he wanted to ask. So I will address that first. So Aiden, which one are you questioning about?
Are they all numbered the same? Like everybody got the same question, the same number, or is it changed?
Yes, not everybody got the same question. They got the same version of a question by number. Okay, so you might have different numbers, you might have a little bit different compounds, but you have a similar by number. So what was your number?
Could I just like share my screen, or do you want me to just tell you the number?
You may share your screen. Let me make it so. Okay, let me clear. Let me stop my share, and I think you'll be able to share your screen. Let me see. Nope. Now you'll be able to share your screen. Is number 5 there?
Yes, ma'am.
All right. So we have 100 milliliters of an aqueous solution containing 77.3 milligrams of a molecular solute, telling you the osmotic pressure. We want to know the molar mass. That is, let's see if I can write on your screen with my pen. I don't know. That'd be nice if I could. No, it's not going to let me. So let me write down that information and you can stop your share in just a minute here. You've got 77.3 milligrams. You have 100 milliliters of solution. It has 5.59.1 torr. All right, so you can stop your share and I'll get my whiteboard out and I will be able to work through that.
Hey, Aiden, I have a question. Do you know how you worked out? Did you convert milligrams to grams?
I honestly have no idea. I don't remember.
Okay.
But
So
I tried to do it. Tried to do it the first time, and I think I kept the milligram. Or no, I think I did convert to grams. But then I also was trying to do the problem the first time, and I didn't realize that I was in freaking Tor, and so I forgot to convert it to ATMs. And so I was doing that last second, but I still didn't get the right answer.
All right, so we know that we're trying to get molar mass, and that's grams per mole. And in your situation, you had 77.3 milligrams would be 0.0773 grams. And then all the osmotic pressure information is what we're going to use to get moles. So we have pi equals these bits here. They told me the osmotic pressure was 59.1 torr, and we have to get that in atmospheres. So torr to atmospheres is 760. The temperature, and I didn't write the temperature down. What was your temperature, Aiden? To 25 degrees Celsius?
Yes, ma'am.
All right. So that'd be 298 Kelvin. And we have to make sure we're using the R that has the atmospheres in it. And my I, since it's a molecular compound, is I of 1. And we'll be able to use all of that to get the molarity. So I'm going to plug my numbers in and see what I get here. 59.1, 760, 298.08206. I get a molarity of 0.00318, and that is molarity. It's moles per liter. Now, I only want the moles. I don't want moles per liter. So I'm going to take that 0.00318 moles, and that's of the solute per liter of solution. And I'm going to multiply by how many liters of solution I have. And you had 100 milliliters of solution. So if I multiply by 0.1 liters of solution, that is going to give me 0.000318 moles of that compound. And that is the last little thing that you have to do before you can take that number and put it right here. Now we know how many moles of solute we have. And when we divide those numbers, that should get you the right answer.
Okay, thank you.
You're welcome.
Dr. Widrum, I also have a question about the exam. It was about question 14.
All right, let me see if I can find question 14 real quick and pull it up. A version of it anyway. Exam 2 preview. Question number 14. Is this the one where they give you a mechanism?
Yeah.
All right. So there's going to be variations of it, and I may not have pulled up yours. Do you want to share yours with me?
Yeah, I can do that.
All right. Let's have you do that. Let me stop my share here. Maybe. There we go. Stop share. And you can pull yours up for me and let me look at yours.
Okay. So this is mine. Okay. I had a question about the CLO. It said that the CLO is a product, but I put intermediate, and I was just confused about like.
CLO is not a product. So if it said that CLO was a product,
that's what it said.
Yeah, that's a problem. Go back up to let me see your mechanism. How in the world? It is not a product. It is an intermediate. So that's an error in that question. If that, scroll back down there, let me look at that. See what it says. You answered intermediate and it said the correct answer product. Okay, so there's an error right there that I need to make sure we get fixed. So this is question 14. If it were a product, which go back up to your mechanism, you would see it in the overall reaction as a product. It's definitely not in the overall reaction as a product. It is being produced and later consumed, so it is an intermediate. And so we'll have to make sure we go through and look for anybody who selected that one and give you credit for it, adjust scores accordingly. Unfortunately, that's going to be a big pain for Dr. Salt, but I'm glad you asked about it.
Yeah,
Okay.
I put catalyst for the second answer, and I realized why it's wrong. But I put intermediate as well for the third answer and got it wrong.
Yeah. So everybody who put CLO is a intermediate would have gotten it marked wrong because it was keyed as a product. And so we have to make sure we fix that for you guys. So I will let Dr. Salt know. She'll have to make some adjustments, and we will. She hates these drop down menu ones because they're a really pain to fix on the back end once we make an error on our keying of it.
Okay, thank you.
It'll take a while, but it'll get eventually fixed, and that will make a difference of 0.33 because it's a partial credit one on your overall grade.
Okay, thank you so much.
I put intermediate and I got it right. I don't know.
You've got a different one probably. There's
It's the same question. Like I looked at the equations and they're the same.
Let me see what I'm going to do. Well, no, I can't do it this way.
I know for mine, I had the same equation, but on some of the, like when it was asking which like compounds are different, or like which compounds are like an intermediate product catalyst, those were different, I think.
Yeah, all of these would be different. Yeah, so I'll go through and I'll look at all three versions and I'll see if there's any additional errors in what got keyed in as the correct answer for those drop downs. So stay tuned, and I will double check on all of them and see if they were keyed right.
Dr. Woodrum, do you mind going to question number 6 on sapling number 23?
Not a bit. Sapling number 23. Question number 6.
Yeah, it's reaction number 2.
Yeah, okay, so it's only one version of this one, so I'll be able to pull it up this way and share my screen. Now, you just gotta go to 6 here. All right, complete the Bronsted-Lowry reaction. You might have different things to start with. But basically what you're going to do is you're going to use the template here and do the proton. In my case, add the proton to the HSO3 minus. Are these the same substances you have or something similar?
I have the same. No, I do not have the same.
Well, I
was struggling.
Let me do
Okay,
mine,
sorry.
and then you can maybe make an adjustment accordingly. I'm going to add an H plus to this. It's going to give me 2 H's. So I'm going to write. Let me get my keyboard out here. I'm going to write H with a plus. No, I'm not. Dang it. Let me undo what I just did to clear it. I am going to. Well, let me clear it. There it goes. I'm going to do an H. And I'm going to do a subscript with a 2 because I'm adding another hydrogen. And then I am going to do the SO and 3, and then I changed my charge. It was minus. A minus and a positive is going to make it neutral. So that should be how it looks. Is that, now tell me what your substance was.
Yeah, no, I got that part right. Like that part made sense to me. It was the base part that just was not clicking for me.
So on the next one, the base is going to receive that. So if it's Bronsted-Lowry, we have to swap the proton. So I've got to donate the proton to the OH minus. That's going to leave me with SO, and I still have a subscript of 3, and then I have to change my charge accordingly. If I took an H plus off of something that's negatively charged, then I'm going to end up with something with a 2 minus charge. And then I'm going to do plus, and what does the OH minus become after it accepts a proton, but H2O.
Okay.
Yeah.
All right, that makes sense. Thank you for explaining that.
Yeah, no problem.
Could you explain that with the second reaction with like the one that I have, because I don't think I put it right.
All right. Tell me what your second reaction was.
It's H2PO4 minus plus OH minus.
Okay. So the base, which is this guy, is going to accept a proton. And how many hydrogens would that leave you with on that H2PO4?
Just one.
Yeah. So the HPO4. And how would that change the charge, knowing that you're taking an H plus off of it?
Oh, I forgot to put the water.
Oh, that's all you did. Okay. Yeah. Yeah. Then the OH minus becomes
water.
Yeah. Easy enough.
Dr. Woodrum.
Yeah.
Would I be able to ask a question from sapling 26?
Sure.
Because I've already done like 7 attempts on it and I'm just stuck.
All
It's
right.
number 8 on sapling 26.
All right. Let me clear what I got on my screen. And let me go back to here. Oh, 26. You're way ahead. 26. Which question?
Number 8.
You know, I have a weak acid. It tells me the pKa value. Solution of the acid has a pH of this. What percent of the acid is not ionized? Assume the H plus in the solution came from HA. All right, so let's get my pen. And let's see. I have a weak acid. And for those of you who haven't worked ahead, don't be freaking out by my work here because you really haven't seen the videos yet. But so we have this weak acid. I know the pKa value in my case was, and yours was probably a different number, but if this is the pKa, then the Ka is 10 to the minus 4.589. Okay, so that's how we get the Ka value. And that for me was 2.5 times 10, or 6. Actually, I have 3 decimal places, so I can have 2.58 times 10 to the minus 5 is my Ka. Okay. And what does it tell me? This solution has a pH of 4. Okay, I'm going to do an ICE table. Give me an initial concentration. No, give me a Ka. It tells me the pH. What percent of the acid is not ionized? All right, so I don't need an ICE table. I know that pH is going to give me my H3O plus concentration, right? So I can make my H3O plus concentration is 10 to the minus 4.853. Let's see what that is. Yeah, we'll have to use that number. I'm sorry. Change signs and take 10 to that number. All right, so I have an H3O plus of 0.000. Well, I should write it that way. 1.40 times 10 to the minus 5. So that's an H3O plus concentration at equilibrium. I don't know how much I put in. All right, so I'm kind of thinking out loud here with you, but let's see. I don't know how much I put in. I'm going to call that X. I started with nothing, and I finished with 1.4 times 10 to the minus 5. So I know that I produced 1.4 times 10 to the minus 5, 1.4 times 10 to the minus 5, and used up 1.4 times 10 to the minus 5. And I know that Ka, which was equal to 2.58 times 10 to the minus 5, is equal to x squared, or A minus times OH, H0 plus minus divided by the HA. So I know it's 1.4 times 10 to the minus 5 squared divided by x minus 1.4 times 10 to the minus 5. And I can solve for x. Now, what good does that do me? Well, if I know how much I started with, and I know what my pH is, then I can get the percent ionized. And whatever the percent ionized is, take that minus 100, that's the percent that's not ionized, which is a weird thing to ask, but that's what they ask.
Okay, wait, the last part. So I would solve for x, and then I would.
Percent ionized, by definition, is equal to the H3O plus concentration divided by the initial acid concentration. Okay, that would give you the percent ionized. We know the H3O plus concentration because we're given the pH. So we know this, check mark. Okay, all of this work is to get you the initial concentration of the acid. You plug that in here, and that'll give you the percent ionized. Subtract it from the 100, and that's the percent not ionized.
Gotcha. Okay. Yeah, that helps a lot. Thank you.
You're welcome.
Dr. Woodrum, I had a question on the exam. So I'm just kind of wondering if it's more beneficial to study from the previous exams on the chem website or like the saplings, because I feel like my issue is just with time. Like I try to work out all the problems like I do on the sapling, and I just run out of time because I'm either trying to do an ICE table or like write out all my units, and like I just run out of time like trying to do it the like conceptual way, and I don't want to start like memorizing, but I just feel like I don't have enough time, so I don't know how I should
Let me
better
ask
study.
you this. Usually if we run out of time, it's not because you're working all the work out, which I want you to do. It's because it takes us a while to figure out what to do to get started with the problem. Do you find yourself having delays in, and this is common, you know, you delays, you look at the question, you're like, what do I do? What do I do? And you kind of play around with it a little bit and finally settle on how to solve it. You find that you're having those delays in recognizing how to get started.
See, like, I don't know. I went through every like practice exam and I felt pretty confident. Like,
Well, I don't think about what you did to get up to the test. I mean, when you were sitting at the test. And
no,
you were,
yeah, I could honest like look at a problem and be like, yes, I know how to. I'm either gonna use an ICE table or I'm gonna use this equation. Like,
so
I
you
feel
did
like
not have you did not have delays in setting it up.
No, I feel like I just,
okay. Well, this one was unusually long.
Yeah.
And so I wouldn't use this one as a judgment of that. But what I want you to do is not do a whole bunch of old exams, because I don't look at old exams to write a test. I'm looking at your sapling. I'm looking at what we do in class. I'm looking at your learning outcomes. And those are the things that I look at to determine what I'm going to have on your exam. I have never, ever looked at an old exam and said, let me make one like this one and kind of write it. So what you should use an old exam for is do all the studying and make sure you're practicing not only the sapling the first time, but you're using my practice saplings. Have you found those? You know where those are? Okay. Use those practice saplings. So the first week you're doing the sapling the first time around. The next week you're doing the new saplings, but you're going back and doing the practice. So you're reinforcing those practices the very next week, driving them home to where you're getting more fluid with it. If you find that there's any one topic where, you know, it just seems that I hiccup on being able to solve it fluently, then go to the end of chapter problems and practice those.
Yeah.
Make sure you're studying the learning outcome conceptually, so you're not having to spend a lot of time saying, ooh, which of these seems right to me, but you really feel comfortable with the concepts. Then once you've done that and the test is approaching, the way I would use one of those old exams is I would pull it out. I would set a timer for an hour and 15 minutes, and I would work through it and see if you have built yourself fluency to where you can get finished with it in an hour and 15 minutes and get a good grade. If you cannot, then you just need to practice more. And if you need to ask me, where can I find additional practice at that point, just let me know. And I will point you in places to go. When you do that practice one, you're going to be really thinking about, where are my delays? Am I having to spend a lot of time thinking about the concepts to decide which one of these questions are right? Yeah. Or am I spending a long time solving out the problem? But when I work through the problem, and I'm working the test, I don't skip over writing my units down. I don't skip over, trying to not write my table, but just I write everything down. So I know it can be done, writing everything down when you do the calculations, if there's not a lot of delay in everything else. So anyway, use those exams as your guide as to whether or not you really do have it fluently enough to where you can finish it in an hour and 15 minutes. And if you can't, then you just need to work more problems or consider your concepts another time around to where you feel more fluid. Once you feel like you've done a little bit more, then you go back, pull out an old exam, set your timer for an hour and 15 minutes and say, can I get this done in an hour and 15 minutes? That's the best way, in my opinion, to use old exams as a guide and a gauge of, am I doing enough to where I can finish an exam in an hour and 15 minutes? Now, I don't fault any student for not finishing our last exam in that.
Yeah. I don't want to keep pulling from that one, obviously, but that one, I definitely was like just running out of time because just like setting them all up and then.
Yeah, that's totally understandable when this last one. And that's why we counted it out of 26 instead of 28. I mean, out of 30, because it was too much to expect freshman student, general chemistry student to be able to do an hour and 15 minutes. Now, some did, but some people are just really very fluent, and it could be done. We had 100 on that exam before the bonus. So it can be done, but it wasn't a reasonable expectation of us for you. Okay.
Thank you.
You're welcome.
Dr. Woodrum.
Yes.
So I finished working out that problem, but I'm still getting wrong answers on sapling.
All right, why don't you take a picture of your work and email it to me, and then maybe I can look through and see if I can find your mistake.
Okay, I'll try to organize it a bit better before I send it.
Yeah, that'll be fine. Just send it to me. I mean, it's not due anytime real soon, and I'll have a chance to kind of look through your work, or you can post it in Piazzi as well, but I don't care either way, because I really don't know where you might have gone astray. I can tell you that since they're carrying they've got 3 decimal places. The most common place I would see is if you truncated your numbers as you work through it, but that may or may not be your problem.
Okay, thank you.
Can you help me with sapling 24, question 7?
Sapling, which sapling?
24.
Okay.
But like just the very last 2 questions.
Oh, okay.
Yeah.
Yeah, there's lots of different portions. Okay, so calculate H plus OH minus of a solution has a pH of 4 point. So you did not get the right answers here.
Yeah.
What was your pH they gave you?
10.43.
All right. Let's see here.
So my thinking before I started was, actually, now that I look at it, I think I know exactly what I did wrong.
Oh, well, I'm so glad I could help. See if you can fix it, and I'll hang around and see if you got it.
Okay. Okay, yeah, I got it. I was using
All right.
TH as POH and trying to do an extra step.
There you go. Got them reversed. Good. I'm glad you got it.
Thank you.
Uh-huh.